Good day, everyone. Before we start, I would like to ask something. Did you know that our planet Earth was known as Blue Planet? Yes, you heard it right. Planet Earth was known as Blue Planet. It is about 71% of the Earth's surface is water covered. Another trivia is, out of 100% of water, 99.7% can be found in oceans, soils, ice crops, and floating in the atmosphere, or water that floats in the atmosphere. Specifically, 97% of that 99.7% of water can be found from oceans. So where is the remaining 0.3%? That 0.3% is the only percentage that is usable by humans. Therefore, 0.3% is usable but unattainable. And this phrase is one of the biggest challenges to the topic that we will discuss for today. So the topic that we will discuss for today is about water resources engineering. And our objectives are: students will be able to define what does water resources engineering means. Students will be able to familiarize themselves to water resources engineering subdisciplines. Students will know the scope of work or duties of these specializations. Students will also know the importance of water resource engineering as one of the civil engineering disciplines. They will also know some of the example projects that are related to these chosen specializations. Lastly, students will know some organizations that involves in the chosen specializations and its benefits.
What comes to your mind when you hear water resources engineering? Maybe it's about water construction, water planning, or etc. Let us define what is water resources engineering. Water resources engineering generally deals with the provision of water for human use and the development of techniques for the prevention of destruction from floods. Water resource engineering also includes the planning and management of facilities that are constructed for this task, like making canals for irrigation and sewers for drainage, and to avoid waterlogging and all other issues related with the usage and control of water. Let me give you a trivia fact. Did you know that water on Earth is mostly salt water with only 3% as fresh water? The majority of the fresh water is frozen in glaciers and the polar ice caps, and the remainder is found as the groundwater. With only a fraction available above the ground, all the fresh water is considered to be available as renewable resource. The supply of pure fresh water is gradually decreasing in the world. The rate of increase in the world population exceeds the rate at which the water supply is increasing, so that there is an acute shortage of water in many parts of the world. What are the requirements to become a water resource engineer? Water resource engineers are expected to obtain a bachelor's degree at minimum. Some states also demand that you attend an AVID accredited program to help with the licensure process, a requirement for all engineers. Obtaining licensure usually involves passing the fundamentals of engineering exam, then becoming a civil engineering intern or an engineer in training for a designated amount of time. The exact requirements for obtaining licensure vary from state to state. Many water resource engineers go on to pursue their master's degree. In fact, 1 in 5 civil engineers pursue higher education. This is not only increases chance of hire but also increases the possibility of landing a higher paying management position.
We all know that water resources engineering is one of the disciplines of civil engineering. However, these disciplines has also its subdisciplines, and these are water and wastewater treatment plant design. So what does wastewater treatment means? It is a process which is being done on the wastewater to change its quality for drinking or other suitable purpose. So, yung wastewater treatment ay isang proseso na ginagawa sa wastewater para mabago yung quality for drinking at sa mga iba't iba pang purposes. Next, water distribution, wastewater, and stormwater sewer system. So what are the difference between wastewater and stormwater? Wastewater or sewage comes from drains and toilets in home and businesses. It is treated at a wastewater treatment plant before being released back into a waterway. While stormwater is rainwater that does not soak into the ground. It flows over roads and parking lots and into stormwater drains which empty directly into waterways. Stormwater is not treated. So, yung pagkakaiba neto, yung wastewater or yung sewage, galing siya sa drains or toilets sa isang bahay or businesses. And it is treated sa water waste treatment plant bago siya ma-release back sa waterway. Pero, ang stormwater, ito yung rainwater na hindi nagsasoak sa ground. It flows over roads and parking lots and into stormwater drains which empty directly into a waterway. So kung yung wastewater is treated, ito namang stormwater is not treated. So yun yung pagkakaiba ng stormwater sa wastewater or ng wastewater sa stormwater. Third is irrigation engineering. It is a kind of civil engineering which includes the study of controlling and harnessing the various natural sources of water. So, yung irrigation engineering, ito yung isang klase ng civil engineering na pinag-aaralan kung paano makontrol and paano ma-harness yung iba't ibang natural sources ng tubig or natural sources of water. The next subdiscipline is river engineering, hydraulics, hydrodynamics, sediment transport, contaminant transport, river morphology, and ice cover rivers. So what does river engineering means? It is a process of planned human intervention in the course, characteristic, or flow of a river with the intention of producing some defined benefits. So yung river engineering, ito yung proseso of planned human intervention sa course, characteristic, pati sa flow of river na may intention na makapag-produce ng iba't ibang benefits. Next, hydraulics. It is the study of fluids, whether in motion or at rest. Hydraulics engineering is an application of fluid mechanicals to water flowing in an isolated environment like pipe and pump, or in an open channel like river, lake, or oceans. While hydrodynamic is the study of liquids in motion. River morphology is a scientific field that concerns with changes in river forms in plan and cross-sections that result because of erosion and sedimentation processes. So kung yung river engineering ay isang process of planned human intervention sa course, characteristic, and flow ng river para makapag-produce ng iba't ibang benefit. Itong river morphology naman ay scientific field na ang concern ay yung pagbabago ng river forms in plan and cross-sections na dahil sa resulta ng erosions and sedimentations processes. So yun yung pagkakaiba ng river engineering sa river morphology. Yung hydraulics naman, ito naman yung pag-aaral ng fluids, whether motion or at rest. Yung hydrodynamics, ito yung pag-aaral ng liquids in motions. So, yun yung pinapakalooban ng fourth subdisciplines natin. So, yung fifth subdisciplines natin ay yung hydraulic structure. So, ito yung mga nakalist like water intakes, channel, spillways and sluice gates, dam, dikes, floodways, mga ganyan. So, yun yung hydraulic structures. So, let us recall the first 5 na na-mention kong subdisciplines. First, water and wastewater treatment plant design. Second, water distribution, wastewater and stormwater sewer system. Third, irrigation engineering. Fourth, river engineering, hydraulics, hydrodynamics, sediment transport, contaminant transport, river morphology, and ice cover rivers. And lastly, the hydraulic structure.
Next one is drainage canals. They specialize in directing rainwater runoff from waterways and roads, controlling irrigation and flooding on farmlands, or diverting sewage and pollution away from water sources. Next one is groundwater seepage, well-designed, seepage control, underground contaminant transport. They are concerned with groundwater system. They manage to control and regulate groundwaters. Next is surface runoff analysis. It is a major component of the water cycle. It is the primary agent of soil erosion by water. The land area producing runoff that drains to a common point is called a drainage basin. Next is hydrology, winter hydrology, climate change. They examine new approaches, addresses growing concerns about hydrological and ecological connectivity, and considers the worldwide impact of climate change. Lastly, extreme events like floods, torrents, mud flows, debris flows. They assure that engineered systems provide acceptable levels of safety.
Scope of water resources engineering. It is a field of engineering that deals with the design of new systems and equipments that help manage human water resources. It is provided into the citizens with a continuous supply of clean, living, and uncontaminated water for drinking. Water resources engineers must create a new equipment and system to expand the effectiveness and efficiency of water treatment and aquatic resource management. The major field usually consists of course, work in surface and in groundwater hydrology, hydraulic engineering, water quality, stormwater management, river engineering, and resource management. This field aims to develop strong abilities to conduct engineering work involving basic concepts and principles, technical analysis, planning, design, and management. Their planning ensures comprehensive, integrated management of water, which balances the needs of people and nature with those of users.
Importance of water resources engineering. In the broader field, water resource engineers advise on sustainable use of resources by conserving water, building dams, and conveying water to users. Their planning ensures holistic, integrated management of water which balances the needs of nature with those of user. So that is one of the reasons why water resources engineering is crucial in this world. So, isipin natin na only 0.3% lang yung nagagamit ng mga tao. So, isipin natin, sinabi rito na yung water resource engineers advise on sustainable use of resources by conserving water, building dams, and conveying water to users. So, isipin natin, paano kung walang water resource engineers? Sino yung mag-a-advise ng mga ganong klaseng bagay sa tao? Knowing na ang water ay nagpe-play ng napakalaking role sa buhay natin and crucial sa ating lahat. So yan pa lang ang una sa maraming dahilan kung bakit mahalaga yung existence ng water resource engineering or yung existence ng mga taong nagtatrabaho nito. Next, why do we need to strive harder to be the best water resources engineer someday? As you can see in this picture, it shows the Philippine water crisis, such as lack of sanitation. 25 billion Filipinos are lack access to sanitation. Lack of safe water. 8 billion Filipinos lack access to safe water. Typhoon impact and suffering children. 55 Filipino die daily from water-related disease. So yung apat na na-mention ay ilan lang sa mga water crisis na nararanasan ng Pilipinas ngayon. Or hindi lang ng Pilipinas, pati na rin ng ibang bansa nararanasan or possible na maranasan yung mga ganong klaseng crisis. pwede rin natin itong madagdag kung bakit mahalaga yung water resources engineering sa ating buhay. So, disclaimer lang na hindi porket naging water resource engineer ka na is automatic mapapawala mo na yung water crisis. Pero, it will help or it has a great contribution kung paano natin mapapalesen yung water crisis na nararanasan ng bansa natin or ng iba pang bansa. One of the best example is the typhoon impact. So, alam naman natin at aware naman tayo na mayroong dalawang magkasunod na bagyo ang dumating at tumama sa Pilipinas. At nakita naman natin, base sa mga nakikita natin ng mga videos and pictures sa iba't ibang klaseng social medias, pati na rin sa self-experiences natin, kung gaano naging kagrabe yung destruction ng dalawang magkasunod na bagyo na ito. Naranasan or nakikita natin sa social medias na napakaraming bata, matanda, at mga animals na na-stranded at humihingi ng tulong para makaalis sa taas ng kanilang mga bubong or mga bata or matanda na nag-worry kung paano sila mare-rescue bago pa man sila abutan ng baha. Kasama rin dito ay yung mga puno na nabuwal, natumba, or bumagsak dahil sa lakas ng ulan at hangin na nagkaroon ng malaking epekto sa mga infrastructures at kabuhayan ng mga tao. Naranasan din natin mawalan ng kuryente at tubig dala ng lakas ng bugso ng ulan. So, kung walang water resource engineer, how much more pa yung pwedeng maging impact nito sa ating lahat. So now, na meron ka ng knowledge kung gaano ka-importante ang water resource engineer and engineering, ikaw ba'y nangangarap maging isa sa kanila? If you are now dreaming or pursuing to become a water resource engineer, why not to strive harder and be the best one?
Here are some examples of a water resource engineer projects. First are the dams. Dams serve as a barrier that restricts the flow of water. Dams create a reservoir that gather large amount of water that may use for human consumption, irrigation, and generating of electricity. Dams also restricts floods for some lower areas. Next is the water treatment facilities. These facilities are designed to improve the quality of the raw water before it moves around or distributed to the community. It is also designed to improve water in the irrigation to make it useful. It also removes contaminants in the raw water to ensure that the water is potable and useful. And then, the water supply network or the water distribution system. It is a system of engineered hydraulic components where the processing of raw water takes place, from the storage area to water treatment facilities until the water is safe to be distributed to the community.
Next example is reservoir. This structure is built to completely store the water that is coming from the dam. There are two types of reservoir. It can be natural or artificial reservoir. Natural reservoir can be a lake, sea, or any form of bodies of water, while artificial reservoir is built by humans. Next example is a spillway. This structure is built to control the release of water that is coming from the dam. This structure also ensures that the water is not overflowing and damaging the dam.
There are some organizations that is concerned with water resource engineering. Here in the Philippines, we have National Water Resource Board or the NWRB that concerns in managing and regulating all water resources in the Philippines. Their vision is to sustain water for our healthy nation and mission to ensure access to safe water supply and make it sufficient for optimal beneficial use. The function of NWRB as a water resource regulator is the insurance of water permits, for the appropriation and use of waters, and adjudication of disputes relating to the appropriation, utilization, exploitation, development, control and conservation, and protection of waters. While in US, they have EPA, or the Environmental Protection Agency. It is an agency established in December 1970 by the Executive Order of President Richard Nixon. EPA mission is to protect human and environmental health and responsible for creating standards and laws promoting health of individuals and the environment. They regulates the manufacturing, processing, distribution, and use of chemicals and other pollutants. The EPA enforces Clean Water Act to keep pollution out of our water. Also, the International Water Association, or IWA, is an open yet ordered platform in which both innovators and adopters of new technologies and approaches can generate creative friction. It is a place for diffusion, benchmarking, and evidence. In addition, IWA is a network of water professionals striving for a world in which water is wisely, sustainably, and equitably managed. Also, they develop research and projects focused on solutions for water and wastewater management. They also have events that bring science and technology to the water sector.
Next one is the American Water Works Association, or AWA. The American Water Works Association is an international, non-profit, scientific, and educational society dedicated to providing total water solutions, assuring the effective management of water. Founded in 1881, the association is the largest organization of water supply professionals in the world. AWA also takes great pride in helping establish two preeminent organizations dedicated to safe water. First one is Water Research Foundation in 1966. The next one is Water for People in 1991. AWA unites the diverse water community to advance public health, safety, the economy, and the environment. Next one is International Association for Hydro-Environment Engineering and Research, or IAHR. The International Association for Hydro-Environment Engineering and Research, founded in 1935, is a worldwide independent organization of engineers and water specialists working in fields related to the hydro-environmental sciences and their practical application. IAHR stimulates and promotes both research and its application, and by so doing strives to contribute to sustainable development, the optimization of world water resources management, and industrial flow processes. Lastly, we have the Environmental and Water Resources Institute, or the EWRI, created in 1999. The Environmental and Water Resources Institute is a civil engineering specialty institute of the American Society of Civil Engineers, or the ASCE, the country's oldest national engineering society. EWRI services are designed to complement ASCE's traditional civil engineering base and to attract new categories of members, non-civil engineer allied professionals, who seek to enhance their professional and technical development.